Greetings to everybody watching. My name is Hussein Noble and my partner's name is Alexander. And this is our project of soft robotics in the course of evolutionary computation and design. We start things off with the very famous quote from Elon Musk that says that evolutionary computation is like eating glass and staring into the abyss of death. But despite that, we persevered and got to the end of it with some very fruitful results that we'd like to share. So, to start things off, for our representation of a robot, we start off with a base tetrahedron that you see on your left side of the screen. We then initialize a face list that stores all the faces of this tetrahedron inside of it. Now we randomly select a face from this list and add a tetrahedron on top of it. After this new addition is done, we delete the face that it was added on from the face list and add the three new faces of the tetrahedron to the face list. We then repeat this process a couple of times to generate a new robot shape each time. But if we were to only select faces from the last three elements of this face list, that is select a face each time only from the newly added tetrahedron, we would end up with a snake-like structure that you see on the right side of your screen.
To actually evolve those robots, we came up with a pretty straightforward representation. We built a configuration list containing 5 types of springs. The first one is air, to evolve the structure of the robot itself, and then the other are bone, tissue, muscle 1 and muscle 2, to evolve the actuating parameters of our robot. Then we generate a list called DNA, containing only digits from 0 to 4 corresponding to those 5 types. That allows us to do crossover and flip a digit for the mutation, and it gave some pretty cool results. So first, RMHC gave us our beautiful worm Turbo, using that arch in its back to propel itself. Then EA1 gave us our precious Robert. He was not that smart, as you can see. It's using its head to propel itself, like bashing its head onto the ground. And finally, even coding in Python can bear amazing results. I present to you our smartest robot, most biomimetic robot that the evolution gave us, Monty the Python. So as you can see, it slithers in a very similar way as that snake on the left, using its whole body to move sideways. So it was pretty amazing to see that even in 1,000 iterations, we can still get something that's actually similar to the reality. So here's our robot zoo containing the 4 robots that were obtained with the 4 algorithms. And the other 5 robots that you can see here are different architecture from the last populations of the EA1 and EA2. So that's giving you some various examples of the architecture that we evolved.
Here we have the 4 curves of our algorithms that you can see on the screen. It is very clear that both the evolutionary algorithms outperform the baseline curves, that's the random search and the RMHC. But we also see that the RMHC performs pretty well, which points to the fact that the mutation functions performs much better than what we had initially anticipated. Above that, the dot plot shows that we were able to generate quite a bit of diversity for each iteration that was run. On the right side of your screen, you see some of our robots walking all together and working together. Lastly, we have our own portfolio website that features the soft robotics project on it, and the link is provided right there. Thank you for listening.